We got a little question about biasing. So, I was trying to figure out which bias of the many that are out there is the best. Like, which one's going to actually get me Class AB? I'm going to make another video about that. But first, don't mind the horrible soldering. This is a test board. I have had so many pieces in and out and re-back in again. So, ignore the horrible soldering. The point of this is I'm using my fluke to measure current from the choke for the front of the transformer to ground or through the biasing circuit. Now, I'm not going to turn the biasing on. I'm simply just going to demonstrate the difference between a box that doesn't have it installed, right? Because if it's not installed, then this just gets soldered right to ground, right to that point right there, which is no different than me just grabbing this point because that just goes to ground. But now I have hands. Okay, so we're going to do this so that's always a 50-watt dead key. Oh, gotta turn the box on first. So up is no bias circuit. So there's my 50-watt dead key. Audio off the charts. I'm running at the box currently at 15.3. Audio. So that's like 450, 460 on that meter. Not to say that's what it's actually getting, but that's what this meter is showing with a direct connection to ground through my meter. So let's see what that is. So 50-watt dead key. It's pulling 170 milliamps. Just trying to ground out that transformer. Right? So it's going from transformer choke directly to ground. Just happens to go through my meter, and I'm measuring 170 milliamps. Okay, now what about when I'm talking? Audio. Audio. So it pulls less current when you're talking, but it's still always actively seeking the ground. So now we're going to keep the bias circuit off. But normally now, if you have a bias circuit, you'd go to this little island, which is after your resistor. But the only thing that connects now this island to ground is your diode, your voltage dropping diode, right? So that's going to give you your roughly half a volt of biasing, because that's what the reverse biasing is on this diode. It's what part number is that? Like a 406 or something like that. 4006, 4806. What do we got? 5406. So it's a 5406 diode. So that's going to roughly give you your half a volt bias. And then I've got my filter caps. I've got a 104 back there, and I've got a little 22 UF. And then I've got these two 10 ohm resistors in parallel making 5 ohms to ground. Now that was something that Gatekeeper, that's his circuit. Essentially he uses a 39 ohm resistor here. So you got your 12 volt coming in. Now the resistor won't step down anything, right? It's just a current limiter. So if you just left this on there, you get 12 volts to your transistors and blow it all up. So you need the diode to step the voltage down and cap it off. So you're getting a half an amp of flow through here as soon as you key on, even if the RF is flowing, right? If I just bypass the relay, amp meter's getting sassy. You're fine. So even if you don't have, RF going through it, you're going to pull about a half amp because of this resistance and that diode. It's just literally 12 volts going through the resistor, getting hot, going to ground. And then the caps are filtering. But he recommended these two 5 ohm resistors, two 10 ohm resistors equaling 5 ohms in parallel to help regulate the voltage. It makes logical sense to me, so I put it on there. That was his circuit. I copied it. Now I changed his resistance to a 20 ohmer, right? So that allows my voltage to actually climb a little bit, and actually more than the voltage, it allows my current to climb a little bit, because this is your current limiter. This is more of a voltage limiter. That's your current limiter. So the lower the ohms, the more current you're allowing to go in. So I'm playing with this one here to try to find exactly what is class AB. So my main point, if none of this was installed, none of this existed, and this was connected directly to ground, like you would get an amp that has no biasing circuitry installed. It was getting like 460 plus, right, on this meter. And it was pulling about 175 milliamps, 140 to 175 milliamps, depending on whether or not you're modulating. Okay, so now I'm going to connect it to the island. So now the current needs to, mind you, bias circuit is off. The current needs to go through my meter to this pad like it would be if your bias circuit was off, right? Because you can turn your bias on and off. You're just essentially providing power to the relay for biasing. Basically just allows 12 volts to come in here and start the circuit or not. So this would be if it was installed, but the circuit was off. Now the voltage coming from this choke has to either go through the resistors and the diode to get to ground. Let's put it back on low. Now, is our 50 watts going to change? I've changed nothing on the radio. I didn't change how much power output. So it's a little less. So let's crank that up so it's exactly. Okay. Right at 50 again. Now what do we have? Okay, so dead key. Now I only have 80 milliamps. It was 170 milliamps, 175 milliamps. Now it's only 80 getting to ground. So it's struggling to find the ground because it has to go through so much stuff to get there. So now, what about when I modulate? Audio. So now it dips from 80 all the way down to 30. Dead key. Audio. 30 milliamps. Before it was 175 to 140. Now what does that do to our peak power output? Is our same 50 watt dead key? Try to get the light out of here. Audio. Now I'm at like 425. So simply having the bias circuit in there, I'm losing on this little 2-pill 425 to like 460, 475 on that meter. I'm losing in the range of 40 to 50 watts just because the transformer doesn't have a good ground. So that's something to consider, that if you're not looking to actually use your biasing, like it was just something like, oh yeah, I want all the options, and then you like never barely ever use the thing because you hook it up to a Cobra 29 that doesn't even have sideband. Now, whether or not the argument is made about the purity of the signal coming out, whether or not it has any harmonics. I'd be willing to agree that yes, a biased amp is usually cleaner. But if you're a mud duck in the desert and you don't really care about exactly that amount of purity, especially with a 2-pill, because you're not really making that much power to begin with, you know, do you really even want to order it, have a bias circuit installed at all? Because, I mean, it's 50 watts is 50 watts, but in the end, the difference between 425 and, 475, the end user on the other side of the guy you're talking to is probably not going to see it. But it's just just a heads up. That's something that I'm seeing. And the next video I'm going to make this bias circuit in 3 different ways that I've seen. One was the BBI version, where you're using, I only have this expensive ohmite, but it's a 10 ohmer, 10 watt. So he's using a 10 ohmer, and then he's using a different diode. He's using a a 5820. Now, a 5820 is only like a 0.1 volt drop. So you're actually reducing the voltage and your current. I want to say when I watched the video of him using that diode resistor combination, and I do not believe he had any of these 10 ohmers in there, but he still had the filter caps. I think he said it was just a class B, because it puts less current through. Now, your resistor is going to run a lot hotter, because I measured how much current is going through this resistor and through that diode. It's an amp versus only the half amp that you get with a higher resistor with a taller or with a higher voltage diode. You get more bias, and you're not making so much heat because you're not trying to dump all but 0.1 volts to ground. Now, mind you, it rises a little bit higher than that, but with that circuit, I was seeing about 300 milliamps going through the transformer. And with this circuit, I'm seeing closer to 425 milliamps. Now, that's under full modulation. So I would say that's closer to AB, or maybe it's even closer to A. I'm still experimenting on that, but if you left all of that diode there and you put this 39 ohm resistor in there, then that also gets you similar to BBI's 10 ohm. Well, it's not BBI's, it's, industry standard, I think. That gets you closer to the 300 milliamps being used up by the 2 pills. So, and I think the industry standard is to go to like a class B, and I think they try to stay away from the AB, and you definitely don't want to do anything to do with A. So, and I've bought a couple of books, and I'm still learning how to find exactly what I need, but I've got the Motorola Data Manual. I've got the Radio Handbook 20th edition, and they both talk about biasing and oscillations, which, 2879Cs have an issue with in the past, but getting carried away. The main point is, if you're not going to use a bias, maybe you don't have one installed in your box, because it does suck down a little bit of power. Maybe there's some way, triple pull switch you can add that when you actually shut the bias off, it actually makes a physical contact, which would not be that hard for a 2-pill. But when you start talking about an 8-pill, and you've got a whole circuit you got 4 individual circuits, one on every 2 pills, and now you're going to try to switch all of them to ground, maybe that would be more complicated. But when you're talking about an 8-pill and you're losing, 50 watts per 2-pill, you're you're losing, up to 200 watts. And that's what I was noticing when I started building the bias circuit for this, is that when I grounded them all to straight ground, just straight C class, and basically just tore out all the bias circuitry in here, because I was like, man, it's not working. I don't understand. It's not pulling more current when I'm biased on, biased off. I don't see any additional current draw. There's no additional heat being generated. So I started trying to develop my own bias circuit, trying to figure out how it works. And so if you're not really into biasing, maybe pull it out, just take that right to ground, or maybe leave the whole circuit there and just take it right to ground, and you'll get some more power out of it. Whether or not it's clean power, that's for you to argue about. 73s.